Now, I have a problem. The question says the equation of a wave. They've given me the equation of a traveling wave. So what I have here, one of my emphasis is on traveling wave. There is this type of wave we refer to as traveling or progressive wave. What is a progressive wave? A progressive wave is a wave that learns to know that travels away from their source. Now, as we get to this, let's see what we need to learn from here. Listen to me. Now, in this case now, we have been given the equation of the wave as this. We are then asked to find the wavelength. Before I go into this thing here, there are terminologies we use in wave. I'll just explain little. The first term is amplitude. If you have a wave moving in this manner, remember, wave exhibits a sinusoidal movement. Now, anytime a wave is moving in this manner, now there are certain things I can explain from this diagram you have seen before you. The number one term is amplitude. Amplitude is the maximum displacement of a wave from their position of rest. Another term is wavelength. This particular thing they ask me to find. Wavelength is the distance between successive crests or trough. This thing here is called a crest. These ones here are called troughs. So the distance between two crests or two troughs is called wavelength. That's not where I'm going to. Now I'm going back to that very question. The question is to find wavelength. Shall we go? Now, in the course of finding the wavelength, what are those things I needed to do? Now, take note, for a progressive or traveling wave, there is a certain equation. Now, anytime a wave is traveling away from their source, are you listening? Anytime a wave is traveling away from their source, two things are happening. Is either they travel in the positive direction or in the negative direction. Anytime they are traveling in the positive direction, then the equation of that wave is giving us y is equal to a sine 2 pi over lambda into x minus vt. That's when it is traveling in the positive direction. But if it is traveling in the negative direction, then it is giving us a sine 2 pi over lambda into vt minus x. So the terms I have here, I have lambda. Lambda is the wavelength. I have v. V is my wave speed. Wave speed is the distance traveled by a wave per unit time. T is time or period. Now, to answering this particular question, even from the question you can tell something. By the time you look at this equation and you look at the ones I've given to you, this one tells you that this wave here is traveling in the negative direction. Take a good look at what I wrote. Now, as we get to that, having known that the wave is traveling in the negative direction, your emphasis should not be on whether it is traveling in positive or negative. Your emphasis should be on how can you estimate wavelength from here. So, estimating wavelength, you have y is a sine 2 pi lambda vt minus x. Now to getting the wavelength in question, let's compare. First of all, A is 15, that is my amplitude. So you have been given the maximum displacement from their position of rest of this particular wave. Now the next thing I needed to get was this lambda. So that by comparison, I would have that 2 pi over 5. Yes, now is equal to 2 pi over lambda. Yes. Compare A to A, Y to Y, this one to this one, sine to sine, this one to this. And so from here, I needed to get lambda. So getting lambda requires me, I can say I want to cross multiply, I can do anything. This one times this one is 2 pi lambda is equal to this one times this one is 10 pi. So to get lambda now, divide both sides by 2 pi. By 2 pi, so that 2 cancels 2, pi cancels pi, and lambda is pi. 5. 2 in 10 is 5. So the wavelength of this traveling wave is 5 meters.